Getting to Mars in 3 days by Caleb Jensen. My subject today is on laser propulsion as a new way of transportation in space. Modern technology, such as the rocket, has helped us to reach deeper into space than was thought impossible just 60 years ago. It has been used to launch every satellite and spacecraft into the cold depths of space. So what is the next step for space travel? For many programs, such as NASA, SpaceX, Blue Origin, and many more, their next big goal is to land on our next rocky planet brother, Mars. Landing there and establishing a base or colony would be a huge step in space travel. Current technology, with humans aboard, allows a trip to be made in about 6 months. This poses some questions about what state to keep the passengers in during this trip. We've been using rockets as our source of propulsion since the very beginning of space travel. Couldn't there be other means of transportation? One theory that is gaining lots of popularity is using lasers to propel spacecraft. To start, it works like a regular spacecraft. You use rockets to get whatever you're sending out of the atmosphere, but once it's in space, you fire giant lasers into a sail, which propels it forward. We know this theory could work because light has energy and momentum. We've seen this effect as we've observed space. Thanks to Einstein's infamous E equals mc squared equation, E being energy and m being mass, we know that mass and energy are the same thing. In this picture, you can see the light from this distant galaxy bending around a much closer massive object. This tells us that light, although massless, has energy and momentum and can behave as an object having mass. So how will light be able to push us in space? On Earth, we're constantly being bombarded by light coming from the sun, and yet this has no effect on us in pushing us into the ground. This is because of how evenly spread out the light is, plus the effects of it are basically zero when compared to Earth's gravity. But using powerful lasers and in a zero-gravity environment, we could have propulsion. Thanks to Newton's third law, which states, for every action, there is an equal and opposite reaction. We know that as the light from the lasers hit a solar sail, it would bounce off of it, giving a slight push in the opposite direction. Although very small normally, in huge directed quantities, light hitting a solar sail on a spacecraft could propel it very quickly through space. The advantages to this system are, it could send a rover to Mars in 3 days and shorten humans' trips from 6 months to 1. Laser propulsion uses the same amount of energy to get a craft to 1/3 the speed of light as a rocket would just to get out of the atmosphere. It can continually be propelled, whereas rockets can run out of fuel very quickly. And rockets are limited by their chemical reactions, but laser propulsion is limited only by the speed of light. I hope to see advances in technology such as this throughout my lifetime. It is innovative ideas like this that will carry us onto the next generation of spacecraft and into the deep beyond.